Hello again. So in this video, we are going to talk about the calibration of the two key parameters, or in fact, the epsilon parameter. We talked about the minimum samples parameter. With the minimum samples or points, we needed the dimensions number plus 1. So this is, for example, in the previous video, I have the clustering here, but I renamed that to clustering 2 so that I will try different calibration parameters for epsilon. So that is a method, a trial and error method. So I put here defined clustering 2 to have epsilon being 7.5. I could actually even define epsilon right here and the minimum and then epsilon is equal epsilon, and I can just change the parameters over here and run the code again and again until I find the best reading. So at 7.5, as you can see, the value is compared to the previous evaluation score, we got 25% over here. However, and how many, how do we do the trial and error? Two things we need to pay attention to. Not only the evaluation metric, not just the evaluation metric, lovely people, but also the number of clusters that you've got. So over here, you've got around 1, 2, 3, 4, 5. This is an outlier, and actually, in reality, in fact, if you take a look, lovely people, this is not even a cluster, and this is not even a cluster. You know why? Me as a marketer, I look at clusters as segments. If you take a look at Kotler's book, one of the main criteria to consider a cluster as, or a customer segment as a customer segment is the size. Look, this size is so low, this size is so low. In fact, this is 50%, I don't like that, but well, and then 34, 24, and these are main clusters that I would talk about. These 1, 2, 3, three main clusters that I will actually be caring for, and the rest is either an outlier or either unmeaningful segments. These are not people that are gonna be into segments. So I'd rather get this code or get this cluster calibrated into 4, 1, 2, 3 clusters, mini clusters, and 1 outlier. So this, you see that? How am I thinking right now? Do you see how am I thinking? So these are very interesting ways that it's an art and science, really. So you need your own view and style. So over here, how many? So for this clustering 2, is it clustering 2? Yeah, because it is DBScan 2. Okay, for this clustering 2 or DBScan 2, I have 1, 2, 3, 4, 5, same exact situation, isn't it? I could even look at it without the percentage. Okay, let's lower the epsilon. What happens if you lower the epsilon? Look what happens. You get a little bit farther and farther away from the 0, but toward the worse, -1, closer to -1, and here worse and worse because it's closer and closer to -1. Now, let's take a look again at 5.5. Also, not good. 6.5, not good. 8.5. So now above 7.5, which is 8.5, so lower than 7.5, as you can see, it's all in the negative. It becomes in the positive, starts becoming in the positive above the 7.5. So over here, it's a little bit close to 0. So closer to 0 means there's a lot of overlapping gonna happen. However, I'm a little bit curious about the number of resulting clusters. So let me take here a close look. Let me take a close look at the numbers here. Wait a minute. Okay, let's just do that. Look, so many clusters and many of them are unreasonable. I don't need these. And then I have 77 outliers. Oh, what? Come on. So you see now the relationship between these scores, the evaluation scores, go in now, I'm gonna here and put this one here and put 7 instead of 6. Oh, I need to run it first. So now, as I am putting this up, the epsilon, I'm getting a little bit 1, 2, 3, 4, 5, 6. So a little bit less lower number of clusters. And it's kind of, you know, look, 10, 17, 32, 49, 82. In fact, I like this, but I don't like the fact that the outliers are almost 25% of the data set. So this is something to care about. What is this again? I think this is a little bit no need. And now clustering 7 is basically 10.5. We've done that. So let's try 11.5, for example. And then also let me try the number of clusters, because indeed it will mean a lot. So now let's see here. I have 11.5. Let's put, this is the 12.5. We've done earlier the 12.5. So let me check. Do you see the score? It's going a little bit higher. It is higher than what I've chosen earlier. Remember, what I've used earlier was a 12.5. So let me check if it's, why don't I use then 13.5? Look, why don't I use it? It is 1, 2, 3, you know, segments, and as I said earlier, and 1 is outliers. Why do you think I didn't go for 13.5? Well, why? I question you. Look, the evaluation score is higher than what we've got. We've got, I think, no, maybe it's not higher. I think our evaluation score was 24. So with that, I'm not going to talk about why. There's another reason why. Look, this cluster has almost all the data. Like there's nothing in the other two clusters. This is a ludicrous situation. I don't know why I can't. So over here, a reminder, the 12.5, as you can see, that's our first solution. It has an evaluation score of 25. This is 24. All right, so how about 14.5? Maybe the evaluation score is higher. Indeed, look how much higher. So why didn't you choose this? Why haven't chosen this? That's a very legit question. Let's take a look why. Ta-da! Only 2 segments, 2 clusters, and one of them is almost all the data set and the other is the rest of the data set. This is not what logic I discovered here. Some logic, you lovely people. Look, I discovered some logic. I looked at the data, I said, okay, we have high spenders, we have low spenders, high spenders. So basically, lovely people, did you understand how we rule? You find something on the corners. The more densities on this corner, this corner, this corner, this corner, and the heart, the most successful the clustering is. Because this means that we have one or multiple variables that strongly affect the clustering and the grouping of the points, and it does make sense. When one variable is very high income, it might also mean that some of these guys might have low spending, some have high spending. Those guys who have a low annual income, some of them have a low spending and some have a high spending. So look at the interesting findings of the purple and the orange. When we look at the age, we'll find out, and the annual income, we'll find out that these orange guys are, you know, older people with a low annual income. Most of the time when you get older, your income starts getting, you know, higher. But these guys are high age, low annual income, high age, low annual income, and low spending. How about these guys in purple? These guys in purple are, in terms of age, not very aging people. You can tell here with the ID, not very high age. They are in between 30 and 40. 30 and 40. So they are in between 30 and 40, these guys. 30 and 40 with very high annual income, 30 and 40, and high spending. So they are in their 30s. These guys are very old. They are in their very old or very young. We talked about. They're actually. Let's take a look. They are mostly above 50. Most of them are above 50. Maybe these two are wrongly identified, only two or something, in 40 to 50. So 40, above 40. So these purple guys are in between 30 and 40. 30 and 40. And these orange guys above 40. So these are 30 and 40. These above 40. So these are younger relatively, 30 and 40. High spending power and high income. These are not like what we are expecting. You are above 40, but you have very low income and very low spending, therefore. Some of us are purple people. These purple people, their age is mid-age, 40 to 50 mostly. Some of them are a little bit until 60, so they are spreading not very much in between a certain age. These guys are in a little bit above 40, and they have high annual income, but they don't spend too much. These have high annual income, they are younger, they spend too much. And these guys are in the middle, you see? And these guys are the transition between this to this and this to this. So that's quite interesting, isn't it? So there's some logic. But if I plot something like this into my plot, I will not find any logic. In fact, there's no clusters to find the logic in the clusters. Look, I'll find most of the population in one color and the rest are very little. Do you want to plot this for fun? This is 24. It's lower than our score. Look at this guy. This is 17.5. It's the highest score. Ta-da! But look how many clusters does it have. It has only one cluster, 195, and only 5 are outliers. Now, I would like to see one thing. I want to see if this is not bad idea for getting rid of outliers. I told you here it's not the best. This is good for clustering. This parameter 12 and something is good for clustering. Now let me take a look here for the purpose of, I know that some of the people watching this video are not here for outliers. Maybe they are also here for clustering in general. I wanted to do it too fast. Okay, how do we manipulate this code? Okay, since we are here, let's do it together. Here we go. Where else? Ta-da! Ta-da! We have to change it here. Then we have to change it here. The rest should be fine. Oh! Spending score. And how about instead of age, could I put customer ID is better. Instead of age, let me put a customer, but I'm not sure how do we write that. Yeah, I did it well. So spending 1, 2, 3, 4, 5. These are the outliers. The rest are not outliers. Does it look like right? Well, why not? 1, spending score and annual income. These are very important for clustering. Seems like here 1, 2 are outliers, probably because of the age. also factor 1, 2, 3, 4, 5. Maybe I put it with the spending score. I put it with the annual income now. Okay, customer ID here and annual income. Okay. So customer ID 1, 2, 3, 4, 5. Okay, okay, that's not bad. Don't you think that this is a better representation of outliers? Everyone else is within this shape. You see, spending score is the key. So all these guys are okay, very close to one another, but 1, 2, 3, 4, 5 isn't. Same here. All this is a straight line. 1, 2, 3, 4, 5. So what do we fathom from here? That the highest silhouette score could be the best one, the best clustering mechanism, yeah, to actually get rid of outliers. So in fact, if I want to get rid of outliers, I am supposed to take care of the calibration, and 17.5, you know, gives me the highest silhouette, and this is how we actually clean outliers with clustering. So be careful. I showed you at the very beginning how do we actually make sense of clusters. So if we using DBScan for clustering, then the calibration method would be finding that epsilon value to be 12.5, not 17.5. 12.5, not necessarily with the highest, you know, silhouette score, but with the value that gives me more meaning and more substance in terms of the segment size. And well, there's another method that will be used to identify the best epsilon. As you can see, this is, we call it the elbow method, and it brings you here. I will talk about it a little bit in class, what does it do, but basically this is the data points 0 to 200, and you take a look here. What is the value that corresponds to this, the elbow? Here is the elbow. The elbow is around this area, and you can see this is where it's not the 17.5. You can see here 17.5 will give you the it is 17.5 is maybe corresponding to the highest silhouette, as we found earlier. But then we have here the elbow is right here, and this is why I started with the 7 a little bit here, actually, the elbow. So if you take a look at the elbow, it's a little bit even less than 10, but in my case I found out 12.5, a little bit higher, to be the best calibrating epsilon. So I don't usually use the elbow method just as a rule of thumb, but I have to explain it to students. However, I basically take a look and see if there's an elbow here. The elbow is around, you know, 7.5 and 10, or actually it is this area from 7.5 to 12. Right? You can tell 7.5 here, the elbow is starting from 7.5. So I start my investigation with anything below 7.5, anything higher than 7.5, until I find a meaning in the data, a meaning that I can explore with finding at least one main variable that can make or give a meaning to the data. However, if you're using DBScan for outliers detection, you need to find also a way, even if it's only 2 clusters, it doesn't matter. This is or 3 clusters. These are all the data in one cluster, and these are the data points that are considered to be outliers, and this is how you clean the data with an outlier with the density the clustering. Okay, thank you so much. I'm sorry if the video is a little bit long, mostly spontaneous.